Okay, so here in chapter 24, we're going to talk about area, surface areas, and volumes. And we'll first start off in this 24.1 talking about areas and surface areas. So areas and surface areas here. And so we first want to talk about what the meaning of the term area is. So this is a good point for discussion to just have your class kind of talk about it, see what their understanding is, and try to meet them where they are at. All right, so what exactly is area, perimeter, volume? These are all good vocabulary words to kind of guide the discussion and to see exactly how they relate them. And perimeter is kind of one-dimensional. We're talking about length. Area is two-dimensional. So we're talking the area within. And then volume is three-dimensional, right? So we'll be looking at kind of what's inside of an object there. So just kind of an idea thinking, relating those dimensions and then with those vocabularies. And then what shapes would give the surface area of a square pyramid? So thinking about the surface area of the square pyramid, so seeing if they could break this apart. So noticing that the base would be a square, and then they would have 4 triangles for the entire sides around. Another good guiding question here, what about a right circular cylinder? So kind of like a Coke can. So this one would be made up of 2 circles, and then if we unfold kind of the side of the can, it would actually make a rectangle that would wrap around. So just kind of helping them visualize what they notice, what they things that they're familiar with to guide all these together. And so what if we have some kind of unusual shapes here? So discussion 2 will kind of talk about trying to get an advantage of having a kind of a base unit or so. So a lot of different things are just going to be different shapes. So something like this, an example might be if let's consider these 2 figures here. So this trapezoid and then this hexagon here. Well, if I use a trapezoid as the base unit, we could actually see that 2 trapezoids together would make that hexagon there. So the trapezoid would be 1 unit, and then that hexagon would end up being 2 units there. So some advantages of relating things to one another. This could be a bit difficult again with kind of this infinity type looking shape, or even the circle, right? Trying to fit those within there. But a common unit we try to use is squares. Squares are a very typical one. And even if things aren't exact, we could always try to kind of estimate. And so we'll look at some examples of that. So our standard unit is going to just be squares, and they don't necessarily need to be 1 centimeter by 1 centimeter, but using kind of some isometric paper, so dot paper, and just saying 1 square could actually be a unit there. An acre is typically, 43,560 square feet. It's roughly, a little bit bigger than 200 by 200. And it's just a little difficult with some of these numbers. So again, the metric system is helpful if we're talking about a centimeter, but really just using a square, for example. So again, talking about the metric system here, what if we consider this question here? How many square centimeters are in a square decimeter? And again, for just conversions here, 1 decimeter is actually going to be 10 centimeters. And so we actually see that we could fit 10 across. Right? And so we're trying to see how many we could actually fit across. Now, here we're kind of just doing it a bit more numerical, but with manipulatives or so, having them to actually just go ahead and draw, let me use a darker color here, having them actually just draw them out, right, and seeing how many of these they could actually fit across there and seeing that they'll actually get 10 and filling them in there. So estimating manipulatives is a good way of actually doing this, and we would see that you could fit 100 of these actually inside a 10 by 10. Now, the other way around, how much of a square decimeter is a square centimeter? So what portion of that is? And once they have their entire grid system here, right, if they're actually able to draw all of them out, and we'll actually see that there is a grid of about 100 of these here, or of 100 of them, we'll see that it's 1/100th of it. So now that we've established kind of a common unit or so, and again, doesn't have to be an actual centimeter, but we're talking about these squares here, how about we try to get areas of some of these figures here using our standard unit? And so let's go ahead and start off with A. And we're going to see A here is one standard unit here. We're going to just see how many squares we actually have. And so we're just kind of tracing around. And then we'll go ahead and count all of them. And we'll trace these. And we actually see that we have 18. So 18 units would be the area of this. Well, something a little bit trickier, perhaps like figure B here, we could go ahead and count how many full squares we have. And here we actually see we have 9 of them. And then we'll try to fill in how many more we could have and kind of doing a little bit perhaps of estimation here. So we see that this square and that one square here. So using this one here and this one here. Now they're both a little bit shy. So if I use that top one there as well to fill those in, then that could probably give me about 2. And then if I look at this and this one here, that could probably add up to about 1 of them. So using this portion here and this one here, those two together probably make about 1. And then my leftover portions, this one and that one there, is probably about another 1 or so. That was probably a little bit over, but then these 2 that we used here were probably a little bit under as well. So kind of giving or taking a little bit there. We'll say about 13 units or so. And you could try this out for some of the other figures. Again, some will be a bit more trickier, but again, just trying to find out where these squares are. So here is one complete square in this case here, and then just trying to kind of match them up. Now this here is not exactly a full square there, but perhaps using this piece there, that might help complete it to make another square. And here's a nice activity for you to try. Try these. So constructing of rectangles here with whole number length sides here to have a perimeter of 24. What is the area of each of these rectangles here? So a couple of activities for you to try out. These are nice, again, with isometric paper there, just doing some perimeters and some puzzles. Nice puzzle problems are always helpful for young learners, very enthusiastic to try on these puzzles here. But let's go ahead and get into this next activity. Oh, and then those just go along with a mathematical practice 1. Again, trying to find some strategies, thinking of some of these with differences between perimeters and then surface areas as well. Okay, so let's talk a little bit more now about surface area. So we are now going from kind of a 2-dimensional object into a 3-dimensional object, but we're still talking area, which is 2-dimensional. So we talked about finding maybe the surface area. We talked about a pyramid, so with a square base here. And earlier we talked about breaking that up into a square and then 4 triangles. So this is what we kind of want them to visualize, right? Could you have some object three-dimensional and then taking away all of the different sides to see if you could get how you would collectively form that. So we're looking at all the different surface areas here. Or I should say all the different areas, right, of all those figures to get the surface area. So here's an example of a right rectangular prism here. And so we'll use our unit squares here, and we see that this right side, that we could actually make about 8 units there. But we're going to want to go ahead and multiply this by 2 because there are 2 sides, which is the right and then the left side as well. So that green portion there would be about 16 units for that surface area. And now let's look at the front, and we see that here we would actually have 6 units. And again, we'll multiply that by 2 because there are 2 sides, the front and the back. And so that'll give us about 12 units there. And then similarly, we could do this for the top and bottom. Again, 2 sides here. So as we count these, we're going to see there's 12 units there times 2. And that'll give us, not 12. Let me correct that there. But will give us 24. And so our total surface area in this case, and I'll probably have to make that small correction there. Let me go ahead and back that up real quick. I'll just correct this one. Should be 24 plus would end up giving us then a total of, there we go, 30, 40, 52. Units. Okay. So here's another activity for you to try out. And so again, sketching a net, right? And this is a little bit more advanced here, but sketching a 3D net, trying to do it on a grid, could we use the same amount? Could we use kind of the same technique here, right? How to calculate that surface area there. And we might need to break up the shapes here. So this is a good discussion about what techniques students could actually use here. What techniques could young learners actually use? And so we'll go ahead and let's actually try this on a more simpler scale here, and we'll talk about our scale factors. So relationships between areas and then our scale factors here. So let's look at these two, the original and then this first object with the scale factor of 3. So it has a length of 1, but the new object now has a length of 3. So we'll say the scale factor is 3. Now we recall here that the area of a square, right, is going to be the side squared because length times width. And so if we're trying to find out the area of the new figure, we would just take that scale factor and square it. And that'll mean that it'll be 9 times as much. So if we have a scale factor of 3, then it would be the new area here would be 9 times, which is 3 squared. And we could generalize this more into saying k squared. So whatever the scale factor is, k, in order to get area, which is squared, because if we talk about area in this case, this would be 9, not just centimeters, but centimeters squared. So we would have that squared factor there. And we could use that to help us out with some more bizarre shapes here. So this octagon, not a traditional octagon here, but one with 8 sides. And we want to find out what the area is here. And so we know that if we have a scale factor of 4 here, then the new area here will end up being that scale factor squared, right? And so this will be a better approach instead of actually drawing the object, which is one option that we could actually have. We could actually draw the object if we like, but we're going to go ahead and use this idea of the scale factor. So our new object will be 16 times the original here. So 4 squared. So if I count what the area is here, we find out that the area is going to be 8 units. So then the area of the new figure should be 16 times 8, which will be 128 units in this case. And think about that, 128 units, that's going to be a pretty big, huge area, right? So trying to draw that out might get a little bit tedious there. And then what about the perimeter here? Well, if we count the perimeter all the way around of this octagon, we see that it is 14 spaces across here for the perimeter. So we would just multiply that by the original scale factor. Now recall that perimeter is still length, it's not area, so we only need the original scale factor, and that's how we're multiplying it by 4. And so we would get 56 units in this case. Okay, so takeaway from here is really trying to meet them where they are at. So seeing what kind of vocabulary, what they envision, and trying to take things apart. So looking for surface area, could they have a shape, and try to break that apart, and then seeing some of those relationships from the scale factors.